There we go. All right, welcome back, everybody, to Foundations of Programming, day 15. We are officially three-fourths of the way there. We are going to finish off what we started yesterday before we cut class, which was, I believe, the SAT data, I think is what it's called, right? For a show of hand, how many of you guys were able to complete it yesterday? Tim, Jason, and Chase? No? Okay. Chase, I'm assuming you're working on the Eliminate Empire. Is that correct? All right.
Yeah, I just finished that, but I was gonna work on the SAT over the weekend.
Okay. Uh, we're gonna go over it. Uh, Nothing against you, but we kind of have to still do it. Have a recording for it for not just you guys that are Jason, Tim, but those that are watching the videos. I don't know if you guys see how many views these videos get, but there's actually people that are still watching, which is pretty cool. And people message me here and there asking for certain things. Let me get my hot sauce out of my screen. But yeah, there's people that still watch. Um, so we kind of have to still go over it just to ensure that it's still for the record there and people can still follow along with everything that we've been doing. I've not coded this in a while. So, I mean, that's good that you guys can see it uh, from scratch. It should be in lesson 11. We should all be looking at my VS Code now. Is that correct?
Yeah, we are.
Okay, awesome. Let's go ahead and open up this README and the SAT data.py. I'm going to go ahead and open this up on the side. And all right. One thing that I do want to cover, because I feel like there's still some issues with like the nesting of data, is we're going to do a quick 5 to 10 minutes discussing. Well, give me a second, guys. My kids are. Thank you, Papa. Thank you. Can I get a kiss? Thank you. Sorry. Was I muted?
No.
Oh, my bad. Yeah, my kid just got home. I apologize for that.
All good.
But so we're gonna go ahead and kind of talk about the nesting of data. It was brought up to my attention. It's still a little confusion here on how this works. And to be honest, probably one of the things that gives you one of the most issues right now is the fact that you're dealing with large amounts of data, specifically the JSON format. Right? This is a lot, and I understand that. And the first thing to take into account when talking about this is uh, how to access data types, right? Data types, or maybe I would say data structures, right? And understanding the basics of how things are grabbed, right? And the first one, seems to be the easiest one, is lists, right? Lists, the way that we grab things is by what we call index notation. And this might be a little like uh simple for some people, but that's okay. We just want to make sure that we're here and everybody understands it. But index notation. So whenever you're working with a list, you need to understand that how do we access items in a list? Well, by indexes, right? Lists are ordered sequences, right? They're ordered sequences. So there is a numerical order to these. No matter what the data type is, we can always rely on the fact that they are ordered by index starting at 0 and onwards, right? 0 to however n amount of items that we have. And I say n as like an imaginary number, like n could be 10, it could be 100, n could be a million. We always start at index 0, no matter what, right? And to access a list, we know that we have to use the index, right? So we have like lists, we would say index 0, and so on and so forth, right? Pretty self-explanatory for everybody here. And the other one is dictionaries, which for some of you who are more familiar with JavaScript, they're called objects, which can be a little confusing, right? When you're learning Python and JavaScript, you're like, well, both of these have, they use a very similar name, but they're two different things in a certain way. But dictionaries are the equivalent of what a JavaScript object is. And the way that we access objects is via key value pairs, right? It is an unordered sequence. There is no specific order to this, right? Just because you add one item first does not mean that will be what you get first whenever you try to return it. It is unordered. The ordered is determined by how it is saved in memory. And this gets a little bit more nitty-gritty to really understand how it works. It pretty much when you go and assign a key value pair, your machine goes ahead and saves it somewhere in your memory, right? With some kind of address. No specific location, it just finds the first accessible location in memory to put it in there. Then you add the next item, and it might be next to it. It might be significantly farther away in memory, but there's no specific order, right? It's like almost like first come first serve, right? You go into a dresser, you open up a drawer, it's open. I'm gonna put something in here, close it up. I got something new that I need to add to this dresser. What's my next available space? It's right here. I'm gonna put it in here, and so on and so forth. So there's no specific order of where in the dresser you're putting things in the drawers, but whatever is open, right? So you cannot expect this to be reliable in regards to a very specific sequence like we see here with lists where they're in order by index. So the only way to access a dictionary is what we call bracket notation, which is fairly similar to how indexes works, right? But when you use a bracket with a dictionary, it's not using the index. It is utilizing the key, right? So you do something like dict, and you'll be a key of, greeting, which will end up returning to you the value, right? We know this up to this point. Now, when working with nested data types or data structures, we can have a list or a dictionary at the top level. But the best way of explaining this is almost like a pyramid, right? That has different levels that you go into it. You can say like a pyramid or like a building that has different levels to it, however you want to see it. But there's always a top level, right? We call that, the root. This is like the top level of it all. And if we were to start with the top level being a dictionary, and we wanted to access the contents that belong in here, how would we do that? Right? You have to identify what level in this building you are at. If you are at the very top level, you want to see what data structure is currently holding all the content at the top level of my data structure, right? And because we know the very top level is a dictionary, if I want to access the top level of this data structure, let's say this data structure is called my object. If I want to grab everything that's within the top level and underneath it, I would have to say my object, and to grab anything at the top level, I would use bracket notation in the form of a dictionary to access whatever key I want to grab, right? Now, let's say the top level is a dictionary, and this dictionary holds key value pairs where the values are lists. Well, the top level starts with a dictionary. So if I want to get any of these key value pairs, I have to use bracket notation and grab them by using the key, right? That'll grab me one of these bad boys. Whether I use the key for this one, or how can I move this? Or I use the key to get this one. But doing this manner of accessing it will grab the next level of this dictionary. So if I want to go to level 2, right? I'm currently level 1. If I want to go down to level 2, of the next part of my data structure, because it is a dictionary, the way to open up this door and go down to the next level is to handle it however you handle dictionaries. So I have to use the key. So I use the key, and it's going to return this data, this key value pair, right? And as we already talked about, whenever you grab a key of a dictionary, it's going to return to you the value. So this is going to return to me the value of whatever this key is holding. But what's the value of this key? It is a list. So this, in turn, returns a list, right? So now, let's say this list holds some other values. Lord, why can't I grab this? Now that I have access to the value of whatever is stored in this key, which is a list, to go into level 3, which is this list, I also have to use bracket notation, but in the form of an index. So if I want to grab 2, I would have to say index 2. I'm no longer working with keys. I have to adhere to the data structure that I'm working with. And we have to do that over and over again, depending on what type of level it is. If the level that you're currently on is a dictionary, then you have to grab the key. If the level that you're working on is a list, then you use the index. And you just do that as deeper and deeper as you get, right? All this makes sense? Now, it can get a little intimidating when you have large amounts of data like this. So you have to look at what the root level of your data structure is. And we do that by checking what is the least indented item in here, right? What is at the very far left of this? And we see that it is a dictionary. So the root of this entire data structure is a dictionary, or since it's JSON, it's technically an object, right? But the way that you access dictionary and objects is the same in JavaScript and in Python. It's still with a key value pair. So if I want to go into the next level, I have to handle level 1 and treat it as such. And because it is an object, how do we mention that we access objects with dictionaries? Key value pairs. So if I want to grab the next items, I would have to grab keys, right? Because I am currently at the level of where there is an object / dictionary. So the only thing at level 1 right now seems to be the key value pair of meta and data, right? Meta and data. So if I want to grab everything that belongs to meta, which is a value, I would have to say, use bracket notation, access meta, which in turn will return another dictionary, right? Another dictionary. Now, to not get confused of where things start and end, you have to use the indentation, right? Something that helps to kind of click on the line that you're working on, right? If I want to access everything within meta and grab its value, I click on it and I can scroll down and you see how it kind of it sticks it to the top of my scroll, and I can kind of see everything that belongs just to meta, right? And even goes even further. It goes into view, which has another dictionary, which has columns, which has a list, right? And it sticks to it. And we do this, and notice that once we get out of data or out of meta, we now enter data. And this is a key, but this one has a value of a list. So you just have to navigate it depending on what level you are. Think about it as if you're like in a video game and you're in a dungeon, right? Each level has maybe a different level boss or a different monster or a different objective, and there's different ways of solving each level, right? The top level is a dictionary, so therefore I have to handle this level of this dungeon in a different way. Whereas once I get into level 2, I have another dictionary. Once I get into level 3, I have another dictionary, right? And then in this dictionary, I have a bunch of key value pairs again. And then I get to one key value pair that has a list as a value. And this is level 4. So if I want to get to level 4, I have to get all the way to level 3 using the keys. So I'll have to get meta, then view, then approvals, and all that will end up returning to me a list of even further objects. Once I'm here, to access any of the objects within this list, I have to handle it as it's supposed to be, which is a list. So I will grab it by indexes. So index 0 will be this object. Index 2 or index 1 will be this one. And index 2 will be this one. Right? I stack corrected. It seems like this list only has one object at index 0, which is all of this. Notice that this is right here, the top level of this list. This list holds one item at index 0, which is an object or a dictionary. But this dictionary has a bunch of other key value pairs. So you kind of have to nest your way into the data structure that you're working with depending on what data structure you're using. Right? Does all this kind of make sense in a way, or am I just kind of just rambling on?
Yeah, honestly, I feel like with this assignment, like the most difficult part I had was figuring out like where to find the data, in the JSON file that correlated with the CSV file and how to grab it. But I kind of feel like once I figured that out, the rest of it, is straightforward.
Yeah. And what you come to realize is that none of the data that you needed was inside of meta. Right? Most of your data was in the data key value pair, right? This is where
Roger.
it was all at. Yes, Tim.
Something that really helped me, I'm a kind of, if I can say visually, it works much better for me. Right above where your mouse is, you have that FOP lesson, that file path. If you click on the little greater than arrows, it'll bring, no, like on the JSON to the right there. And then go to the meta. You can navigate it this way, and it tells you what you're working with at the next level. And it was that was super helpful for me.
That's actually really, really good. That's pretty cool. I did not know this. Meta view, that is awesome. I didn't know this myself. Yeah, absolutely. This is pretty cool. Okay. Yeah, thank you for that, Tim. That's a really great tip. I did not even think of this or how this worked. That's pretty cool. Never even noticed that. Yeah, awesome. Good tip, Tim. But hopefully that helps either the visual part or even utilizing this to navigate through this large piece of JSON.
Yeah, I would say this part was much more difficult than the previous problem we did. Whatever that. Yeah, for some reason, the award winning one, like the JSON file was more straightforward in terms of the organization, but this one was much more difficult.
And it's gonna happen. You're not always gonna have something as straightforward as the Nobel Prizes one, right? You might have something as complex as this, where half of this stuff might not mean anything to you. So you have to get really good and comfortable, mainly, of understanding the data types that you're working with, so you're able to navigate them, right? And then make an educated guess of how to or what information you're looking for and where it's at. But enough talking. Let's go ahead and get into this so we can get into today's lesson. So for this project, we need to import JSON. We're going to write a class named SAT data. And this class needs to read the sat.json file and write the data to a text file in a CSV format. Right? So let's look at it. It gives you a small description of what CSV is, but we talked about that yesterday, so we won't dwell on that. Let's get into the class. Right, the SAT data is supposed to have an init method. And the init method is supposed to read the file and store it in whatever data members that we prefer, right? I don't see here that it's supposed to take anything, right? It just says that it's supposed to read the file and store it in a data member, right? It doesn't say anything about taking in any arguments or setting a parameter for a file name. So we'll just leave it at self. But we're supposed to create some kind of data member that's supposed to have all the information from sat.json. Well, we're going to start by opening up that JSON file by saying with open. And then we have to put in the file path of where this is located at. This Python file is in the same level as sat.json, so I don't have to strictly give it the file path, I can just give it the name of the file, which is sat.json. And then finally give the second argument of our open method, which is what we want to do, which is read. I just want the content of this file. And I'm going to say as in file because we are grabbing information from it, right? Finally, I want to load in this JSON data. And as we already know, to take in JSON data and convert it into something that's readable in Python, we have to leverage the JSON module, right? So we have to say something like json.load. We want to load in this JSON data that's currently being saved into the in file. And I'm going to save this somewhere. I'm going to say data is equal to json.load in file. And then once I have all this data saved into some kind of variable, I'm going to give the attribute of sat_data is equal to data. And this should have all the information, and we'll test it out in a bit just to make sure. And the second method is going to be to define a method called save as CSV, right? So save as CSV. We need self. And it takes as a parameter a list of DBNs, but we're going to put a halt in that real quick just to ensure that we have the data that we're working with. So we're going to say return self._SAT data. Before I even try to work on any other information, I need to make sure that I'm actually grabbing the information. So let's go ahead and instantiate a SAT data object. So I'll say SD for SAT data is equal to, call the class and instantiate it. And then I'm gonna call the method save as CSV and see what it does. And let's make sure we're printing out the result that we are receiving back from the method. And let's run this. And let me navigate to the directory. And let's go ahead and run SATdata.py. And it works successfully. I'm able to print out the entirety of that JSON file, and it's readable in Python. So I can see here. Now, it might not look pretty, but that's okay. I don't necessarily need it to look pretty here. I can just use the file itself to know how to navigate through it. But this, what at least it tells me is that I'm able to load in the JSON data successfully and convert it into something that's readable in my Python file. So let's go ahead and clear up our terminal. But at least I know that this is working. Now, let's actually get back to the method at hand. And the way that it's supposed to work is we're supposed to take in a list of DBNs as a parameter, and we have to do something with them. Now, before we do anything with these, I need to know how to navigate to grab the information, right? I'm supposed to take in this list of DBNs of district bureau numbers and save a CSV file that looks like the SAT College Board CSV file, which is this one, right? So grabbing these specific DBNs, I should be able to return something that looks fairly similar to this, where I have the school name, the number of test takers, critical reading mean, mathematics mean, and the writing. So I need to be able to use these DBNs to grab the rest of this information here that I currently do not have access to. Well, let's look at where it's at in my sat.json file. As we already discussed, I kind of hinted to earlier that we don't need the meta. What we really needed was the data key value pair, because the data key value pair has a value of a list of lists. And I know it's a lot. Let's go ahead and see if we can find where it starts. Here we go. The top level of this object has only two keys, meta and data. The only key value pair that I am interested in is this key value pair data, right? I can talk about how I reached this conclusion, but if you were to read through meta, you would see that nothing that you're looking for is there. When you get to data, you'll see that this is holding a value of a list, right? And we can even see that the ending of this list is the entirety of this value. Right here is the purple, right? But this list has a list of lists. Right? Looking at index 0, we see that the first list has some different data here that not all of it is relevant to me, but I believe at index 8, we see a DBN, followed by the school name, followed by 4 different numbers that seem to match the amount of numbers that I need for the critical reading mean, mathematics, writing, and also the number of test takers, right? These are the 4 numbers. If you want to better understand if these are actually the correct numbers and which is which, the meta actually does tell you that, but you would have to kind of look through it quickly. You can see something like columns, right? And the columns, it tells you what each column is. The first column, the second column, third, create at, create meta, updated at, update data, meta. And then we see here that one of the columns is the DBN. It has all the list of DBNs. The next column is school name. The next column is number of test takers. And then critical reading mean, and so on and so forth. So actually, the metadata does tell you how it's structured. And once it's done telling you how it's structured, it eventually does get into the data column to show you the actual data itself. So the columns inside of meta actually describe how the data p-value pair is structured. So with that, I was able to reach a conclusion that these last indexes within these lists are actually the information that I'm looking for. So using the list of DBNs that I'm supposed to pass in as arguments, I want to navigate through my SAT data that I loaded in, reach this part of my data, look for the respective DBNs that I'm looking for. And once I've encountered them, I want to grab the information that I'm currently lacking. All this makes sense so far. All right. Well, let's start that. In my save as CSV, I want to access the self._SAT data, right? And what did we say the top level of this data structure is, Chase?
It was meta, right?
Yeah, it's an object, right? It's a dictionary. But yes, the top level does start with key value pairs, which is meta and data. So if I wanted to grab all the information here, how would I nest myself into this next level? No worries, take your time. Right, this here is the entirety of SAT.json. We saw that, we printed it out. So I know this is some kind of data structure. It is this data structure.
Would you just do the self dot underscore SAT data and then bracket notation meta?
Yes, you're on the right track. Not meta. I want data, right? Because the information I'm looking for is
data.
not in the meta key value pair. It's in the data key value pair. So I'm going to go into data, and this will return what? Right? If I grab the meta, or sorry, not the meta, the data, right? This returns to me what? This is a key. Data is a key. As we know, when you access a dictionary or an object using the key, it returns to you the value, right? And what is the value of data?
Oh, it's like all that information, all that, the list of all those lists.
Correct, right? The key is data, and the value is a list of lists. So this, when I call SAT data bracket data, will return to me the value assigned to this key, which is in turn a list. So by doing this, I now have access to a list. Now, how do I grab access to all these other lists within this list?
We can just do a for loop.
Correct. I want to start a for loop on this because I know this is a list. So I can say for, I can say data, but I don't want to use the same naming conventions as other stuff I already called. So I can say for maybe data list in self._ct data. This will start a for loop around the value that belongs to the key of data, right? Which would then give me access to every single other list nested within this list, right? And now that I'm within here and I'm accessing all these different lists, I want to check the list to see if they match my DBN. So because this is another list that I'm now accessing while doing this for loop, how do I grab this? The DBN.
Can you just do another like nested for loop in there?
Yeah. I can say for let's say we can say column for column in data list. All right, we can treat this as columns. Which then starts a inner for loop within each list that I'm for looping through, right? So the first for loop starts at index 0. And then we start a nested for loop, which then loops through the items of index 0. And eventually I'm going to get to this. So I want to check if one of these items within my DBN list is within this. So I can say if column in, and let's pass in the DBN's parameter. If column and DBNs, which will then in turn check if whatever I'm passing within a parameter in this list is within the DBNs of data. If they match, I want to do something, right? And that is, I want to grab the school name, the number of test takers, and their means, and then do something to them, right? Well, to do that, I have to write into a CSV file. So somewhere I have to say with open, I need to open a CSV. Let's see what we're supposed to call it. I don't see any specific name, so I can just call it whatever I want. sat.csv. I want to write into this new file as out file. And then we can nest all of this within here. So while this is open, while I open this CSV file, I'm going to start this for loop. And as I grab what I'm looking for, I'm going to go ahead and append it or write it into this CSV file, right? So at some point, we want to say out file dot write, and then I want to write the column in here, right? Because we know the column is the DBNS that we're currently looping through. So let's start a interpolated string. I'm gonna say column, comma. How do we do this? Column, then we can say data list, and then give it an index. Okay, so what I'm trying to do is I'm trying to grab these items and add it to this interpolated string. right? This list right here, or this for loop for column and data list, is looping through here. I know that for the most part, these all have the same structure. If something is missing from these, it's either 0 or no, or an empty value from what I can see, right? But at no point are any of these missing any of these lines, right? Even if I encounter one of these pieces of data to have something like 0 or no, it still has it, but it all has the same amount of indexes. And we can see here, there's one school that has nothing in the test takers or their means. So I can make a conclusion here that the indexes are constant. So I can add the items by saying data list and then grab the index of what I'm looking for. This is index 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, so the DBN starts at index 8. So this interpolated string will start looking like this, where the first one is the DBN. The next item, which is a school, is the next one in the index. I can say data list index 10 for the number of test takers. Data list index 11 for the critical reading mean. And I'm going to keep doing this, kind of formatting my string exactly how I want it. And I believe there's 13 here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. So we have 13. And this kind of pre-formats that list or that line for me, right? So then I can write it in there, and it should look good so far. And it's going to keep doing this, right, for each one, right? It encounters, let's say we're doing the for loop. We're currently looking for this one. It's going to encounter it. And if it encounters it, it's going to write on the information for that specific DBN. Once it's done, it's going to continue with the for loop, right? And eventually grab the next DBN, and it's going to do that for all of them. So as it stands right now, I think it should work. And I have a typo here. Let's see how this is working. If I run this, I get an issue of set unhashable type set. Tell you what, let's go ahead and do a print statement. Let's print out the column. Make sure we're grabbing the right information. And we are not.
You're still printing the entirety at the bottom of it.
Oh, my apologies. Are you sure?
You say print at the
Yeah,
very
but
bottom.
I'm printing whatever is returning from save as CSV, right? And this should only be returning. Oh, my apologies. I'm returning this. You're right. Let's go ahead and remove this again. There we go. We're getting something readable. Notice that when I do encounter the column, I'm not doing anything yet, but I am able to print out the column that I'm currently on. One of them is 303, 294, 450, and 418. So I'm getting it. But I'm not grabbing the information that I'm looking for. Let's see if I can print out data list to see what it's actually giving me. Okay. And yeah, I am able to grab it. We see here. But there's something wrong with the way I'm doing it. I think right here, I'm missing it. I'm missing curly braces. There's a small syntax error. And it looks like it put them all the way at the end. That's funny. Okay, let's run it again. Let's go ahead and clear this. Let's get rid of these print statements and see how this works. Okay, nothing printing out, but let's look at the file that we created, sat.csv. And it's working to a certain extent, right? Because it's not formatted as we want. We see here the first one. But then, when we get to the next one, what happens? Well, if you recall, when writing into something, we have to specify a new line. So I'm going to go ahead and say /n at the very end of this, and let's see how that works. And there we go. We have our formatted CSV to a certain extent, right? There's something missing here. And we'll talk about it in a bit. But I was able to loop through. I got into the nested area of where I was looking for. Once I got there, I accessed specifically the indexes that I was looking for and used that to create an interpolated string to format how I want this to look in my CSV file. Now, so far it's looking like what I want it to be, but I'm missing this, right? Which is the header. Well, what I can do is, before I start this for loop, I can just say outfile.write and go ahead and put it in here because I only have to do this once.
But you also need to sort the list, and if you put that in the first line and then sort it, it's being wrong.
Okay. Thank you, Tim. Yeah, we can definitely do that afterwards as well. Whichever one comes first. I haven't done this in a while, so I probably didn't remember that part. But yeah, we can handle that a bit. Thank you for bringing that up, Tim. We might have to move when we do this, but let's keep it like this for now. Number of pass takers, critical reading mean, mathematics mean, and writing mean. And then once again, at the very end of it, new line. Run it again. And it's looking closer to what we wanted. Now, Tim brought up it has to be sorted. Is that correct? In ascending order. So what we can say is dbns is equal to dbns.sort and see what it looks like. And I'm getting an issue because of none type. If columns and dbns this might not be doing what I think it's going to be doing. I think what it's doing is I'm getting none. Why am I getting none?
Python also has a sorted method as well as sort. That's a little different.
Yeah. I just want to make sure. I don't know why it was giving me an issue. Why did that one work and the other one didn't? That's weird.
Sort modifies the list. Sorted produces a new list to assign to that variable.
You're right. Absolutely right. Thank you for that, Tim. I appreciate it. And you too, Jason, for that the sorted one. But we see here, this looks like it's sorted. We have ones and then twos. And the twos, they seem to start at 2, 3, and 4. We can find something that's changes the letter. We use this to see how this one works with a K. Just to make sure that we have it working as intended. And if I run this, the K is added at the end. Yeah, it's working. Pretty straightforward. Do I have any questions, guys?
In the README, it also asks you to handle the potential of a comma inside the school name, because when you write it to a CSV, if you don't make that deliberate, then it'll separate it with a comma into a digital column.
That is a good question. Did you guys handle that? Were you able to achieve it? Is that what you're asking? Okay.
No, I was able to do it, but I figured you want to do it for the demo.
Yeah, I did it. I'm just gonna say like I was able to like do the problem, but I did it in a lot more code than what you did.
Okay. Let's see. Let's look for one that has a comma to make sure we can handle that. Right here, this one. Let's replace the first one, or what's the smallest one? This one right here. And let's see how this handles it. And yeah, that's a good question. So we have here, you're absolutely right. It took the string and it split off into something that we didn't necessarily want. So there are a couple ways of doing this. For one, once we find the item we're looking for, we need to know how to treat index 9, right? Because index 9 is the school. What we could probably do is it wouldn't make sense to strip it. What we can do is maybe, I'm thinking dot replace. Let's see. I'm a little rusty on these. Python dot replace. Yeah, I'm thinking dot replace is what we'll do. And the way I'll probably handle it is when I call this, I'll say dot replace, and I'm going to replace the comma with I believe the escape character for that would be something like this. Let's see if this works. I don't know. Don't ruin it for me. It did not. I even got unmatched. There's an issue here. What do you not match? How can we do this? No one tell me. I want to replace something with a way that the CSV. Let's go with CSV escape, comma. Is there any documentation for this? I don't know off the top of my head.
In the
I
README,
wish
it tells you how to handle it. It just
does,
doesn't tell you how to implement it.
does it? Let's see. Uh, to enclose such names in double quotes in your CSV file. If you open a CSV file in text editor, you can see what's it. Okay. All right. I see what. Okay. Interesting. Then we can say something like this. Let's go ahead and remove the replace. Oh, Lord. And I can say comma in how can I do this? Not liking this. What was the syntax for this? There is a comprehension for how to do this. Give me a second. I forgot how to do the comprehension. I don't use it often. We'll say I want this to have this if in data list, else okay. Yeah, I think I'm on the right track here. Let's go ahead and say something like this where we say data list index 9 if comma in data list else data list not liking this. I mean, I could say something like if in data list index 9 data list is equal to we can do an if else statement where we can check if there's a comma inside of index 9. And if so, we're going to create a temporary variable that's going to hold the formatting of that school name. And then we can add that in here. School name is one way of doing it, because I can't remember the other way. Else, we just add data list index 9. Let's
Would
see
it
if
be-
this works.
Yep, that should work. But instead of doing that, why not make the else for the variable instead of the entire line?
What do you mean?
You say if there's a comma in data list, then school name equals this, else school name equals that, and then put school name in one line.
I mean, that's one way of doing it too. No, I mean, you're not wrong, right? So there's different ways of doing it. I was trying to do a much more efficient way of doing it, but this kind of gets us through this assignment, right? But I mean, this is one way of doing it. Essentially, you just want to be able to format it. I was trying to do some kind of logic here, which for the life of me, I just can't remember how to go about it. Where I do some kind of comprehension where I will return a variable if it meets a condition, else the other one. I'm better at it in JavaScript than I am in Python, because in Python it's not used too frequently. But you're absolutely right. We can either have school name be a formatted version or not, right? If not, just keep it how it should be in raw format, and they just, only have this written once, which sounds like the more efficient way of doing it. So you don't have this written out twice, where it's just like a long piece of code. But as long as you're able to understand that that is a way of doing it, that's what makes me happy. Does everyone understand Tim's way, or do you want me to show you guys what he's referring to? Okay. All right, but this is one way of doing it. I would like to show you guys the other way, because what else could happen here that I don't know if it brings it up. We have double quotes. What other thing can we encounter within this assignment that we have not encountered yet?
A duplicate DBN.
Not necessarily. I don't know if there is a duplicate DBN.
One thing I noticed with some of these, as you said before, like some of the means don't have a value at all, and and in the JSON it'll have the word null or none. And I used an enumerate method to essentially go through and change the nuns to as an empty string to fix that.
For every single one?
Only ones that only if it had an empty string, or if it was none, change it to an empty string.
I'm glad you did that, Jason. That makes me happy. But yes, that's exactly what I was getting at, right? If there is a value that had like no, there would be nothing here, right? And maybe that's not good. Maybe you want to put at least like none, right? At least put the word none. But if it was empty, it would just be like comma, like 59 comma, and then the next piece of the column.
But what I'm saying is, I made it look like how the other CSV file looked. If I actually had comma, because that's how it was working, as opposed to none.
Is that how they had it? Let's see. Okay, they did. Yeah.
Yeah.
No, that's a great example.
Yeah. So I just had it look like that.
Let's see. Let's go and copy this one. And see what this does. Yeah, none. Yeah, no, I mean that's a good point, right? You might want to take that into account. If it's equal to none, then have just comma. I'm glad you went the extra mile and you realize that. Hopefully this walkthrough kind of helped understand a little bit better. I know Tim and Jason, if you guys already completed, that's good. For you, Jason, when you do work on this weekend, hopefully this helps. Any other questions, guys, or remarks in regards to the assignment?
I guess can I show you some of my thought process? I guess how I was able to figure all this out, because it took me a long time.
Yeah, absolutely.
Okay.
It always helps to have somebody's insight.
Okay. Sorry, I gotta find my own now. Okay, do you see my solution? Am I sharing the screen?
Yes, you are. I'm seeing your. Yep.
Do you see my code? Essentially in a Notion electronic notebook.
Uh-huh.
Okay, so I literally just went piece by piece by piece by piece. I broke up, essentially the README into every little thing that I did and literally just went down the list, you know, just yeah, literally just one by one, like piece by piece by piece. And this took me 4.5 hours to do today. It's but just sticking with it because I felt like I wanted to have a win, but I kind of felt like it gave me confidence, that if I could break down every problem and just take my time, I'll eventually make it through, so
I love to hear that. No, absolutely. And sometimes you need that time and that headache, because you get a lot more than you would, if you just like gave up or found the answer or whatever. I'm sure you probably learned a lot after doing this assignment. And this will come in handy. And this kind of what this also helps you is your problem solving skills, because a lot of the stuff in coding is it's honestly just problem solving skills. Some critical thinking, how to dissect a problem, break into smaller problems, right? And then how to engage it too. Where do I start, right? One of the biggest issues with beginning coders is like you know, I know how to do variable, I know function, I know for loops, but then I see the problem and I just don't know what to do. I'm just like lost. And that's the biggest thing I hear is that I just don't know how to begin this. But I'm seeing that you guys are getting better at that, at being able to dissect the problem and engage it effectively. So pretty cool. Good stuff. All right, let's go ahead and go on our first 10-minute break. Then when we come back, we're gonna go ahead and start the next part was going to be the Space Invaders module. So I'm going to go ahead and pause the recording. I'll see you guys at 6:46. All right, let's go ahead and come back to today's lesson. So we started talking about this a little bit yesterday off camera.
Hey, Roger, real quick. There's something I've been meaning to ask you for like 3 days. I keep forgetting to ask, but did you say there was a way to record the lectures like as you're watching them? Because I remember I thought you said something about you needed to have the lectures quicker than if you just waited for them to be processed, like the next day, if there was a way.
Yes, I like OBS Studio. It's an open source software that you can download. It's fairly simple. This is what the application looks like. Um, you open it up and it will immediately start kind of showing you what your screen is looking at or where it's going to record. You can set up specific scenes to record different things. Um, Navigate the settings of your sources, audio, so on and so forth. But the simple is just start recording, and then once you're done, you stop recording, and it downloads the recording to your computer, and you can use it later. It's a fairly simple software, nothing to it. But OBS,
I mean, does it pretty much record your Zoom call?
yes, it records your entire screen. So anything that you
Okay.
have on your screen running, it'll record it. If you have a webcam, you can also record your webcam.
Okay.
Yeah, so I recommend OBS.
Okay.
Anything else, Jason?
No, no, that's it.
All right. Okay, let's go ahead and move forward. So as I mentioned before, yesterday we were talking a little bit off camera about today's lesson, which is Pygame, right? So Pygame is a small extracurricular lecture that I developed. It wasn't originally placed in here, but because of the complexity of the object-oriented assessment, um, people struggle to be able to handle or visualize what classes and objects are doing. Pygame is not a module that you'll be needing for the immersive program. We are only using it as a tool, right? Very similar to how we had like Postman to use the tool to ping APIs. The Pygame module is built into Python. And what it allows us to do is to be able to open up some kind of a screen on our computer that's strictly written in Python code, right? There's different ways to create different Pygames, but the way that we're going to be doing it is going to be using object-oriented program, right? The main sole purpose of this assignment is to be able to create classes, instantiate objects, and be able to visualize something that our objects are doing. And it's going to be using a lot of the key things that we've talked about when it comes to classes and objects. Now, like I said, it's not something that you are going to be tested on, so you do not need to memorize any of the methods that come with Pygame. All the methods that we are going to be using are from the documentation. I pretty much already kind of filtered them out for you. I haven't worked on it in a while, so I might be a little rusty on some of these methods. So there might be a little lag here or there, just trying to figure out what's going on. But this assignment should take you from start to finish on how to create a simple game using Space Invaders, right? The main sole purpose on this, as I mentioned, is just to be able to visualize what our objects are doing. We do have different people with different ways of learning. Some people can just take something like this and be able to understand what it's saying. Some people like to see it written out for us, right? We already handled the installation of Pygame off camera. For those of you guys that are watching or interested to kind of try out this assignment, you want to visit the Pygame documentation. For the getting started, you want to use this latest version recently of installing Pygame. You can run this command on your terminal, which will then install Pygame. I recommend creating a virtual environment, which I believe we actually did cover a while back in the class. But to create a virtual environment, you would essentially use Python. You will prefix it with -n for module, and the module we want to use is venv. And then you would name your virtual environment whatever you want. You can name it Pygame -env, whatever you decide to call it. When you're ready to activate the virtual environment, you're going to start with source. And then you're going to specify the file path of where your virtual environment is located at. You'll say Pygame-env. Then you're going to add the /bin and /activate to the very end, and then press enter. This should then run your virtual environment where you can install any kind of dependencies. If I haven't covered what virtual environments are, essentially, when working with virtual environments, you are giving almost like a sandbox or a clean slate of where you can install different things that are outside of the realm of your virtual machine. And the reason why we do this is because, as you may know, everything is constantly being updated, right? There's different versions of Python, JavaScript, there's different versions of Pygame, right? And then there's also different versions of Django, React, what you guys are going to be exposed to in the immersive program. And you're not always going to be working with the most latest version. When you go into your first job, you're going to realize that some people are going to be using outdated versions of different stuff, and they just haven't updated to the newest version. But the application that you might be working on might still be on, let's say, version 2.5, right? If you come back and you revisit your project and there's a new version of React and now it's like at 3.6, and you try to run your program with the new version, you're going to find out that a lot of stuff is not going to work, right? Because stuff becomes unused or it gets updated to a newer version and it works differently. Some methods might not be no longer relevant, and your project might not work. So the way that we handle this is we create virtual environments where we have specific versions of the different installations that we have, and it stays constant. And when you're ready to run that program again, you can just run that virtual environment, which still has that version of the dependencies that you had, and it should run the same, right? So you want to create a virtual environment. That way, anything that you install involving Pygame isn't directly installed into your virtual machine. It's all within a virtual environment that you can utilize. Now, let's kind of start this off. We talked about how to install it. This is a little outdated, but if you're on Mac, this should still work. You should be able to run this command to install it, and then you would run the python 3-m pygame.examples.aliens to give you a small demo of what it should look like. And I think I can kind of copy and paste this here to see how this works. As you see, when you run this command, it's going to open up a demo window to ensure that Python was successfully installed into your virtual machine and it's working as intended. Now, for everything that's covered here can be found and located at the Pygame documentation, which is pygame.org. As you saw earlier, you can go to Getting Started and it will show you there. We're going to be using the documentation a lot today to kind of start our program off. I created a small cheat sheet. Now, this is kind of when I first started teaching this and working with GitHub READMEs. So this might not be the best formatting. So I do apologize for that. But if you ever want to reference something, you can always come back here and find a quick method of how that works. Now, let's go ahead and kind of get this started. If you give me a second, I unfortunately did not get this ready as I expected. Stand by. Let me get this opened up. I apologize for the delay. All right. Okay, let's go ahead and resume. How do I? All right. I'm going to go ahead and open up a new file. So in your lesson 10, what you're going to do is you're going to create a new file. And this file is going to be called main.py. And this is going to be the main file where we're going to have the game loop of our application. Now, for those of you not familiar with game loops, so what is a game loop? Am I still paused? Can you guys see my screen or no?
Yeah, we can see. Wait, did you update it or are you still in the README?
Let's see. I should be showing my VS Code right now.
Yeah, I can see it.
All right, yeah, you're gonna create a new main.py. And this main.py is what's gonna hold our for loop for our main loop. So games, very simple games, they all work in what we call a game loop. Right, everything in games is essentially some kind of very long loop. A good way to explain that would be, let's say you have a variable called true and false, which means, like, let's say the variable is called running, right? And whenever running is set to true, what's going to happen is you're going to start some kind of a while loop that's going to keep doing something over and over again when running is equal to true, right? Within this while loop, we're going to have the overall main concept of what should be happening throughout your game. What happens is your game runs in frames, right? It runs like 1,000 times per second, and every second, when it's running thousands of times, I think maybe thousands is exaggerating, like hundreds of times, it's checking what's happening on your computer, and it's constantly checking what's on your screen. It's checking if a button was pressed, whether your mouse was moved. And then every time it checks this, it's going to update your screen to represent the changes that were made. If we had an image on the screen and I moved it 2 pixels to the right, this while loop, while it's constantly running, is going to identify this change and then represent the change on your screen, right? And we want this loop to continuously run to check anything that's happening on my game to therefore show it on my screen, right? This is what we call the game loop. Now, to start this off, we're going to import Pygame. Pygame is going to be the module that we are going to use for the entirety of this module. And we need Pygame so we can use some of the methods that come with it. And you can follow up through with the README. This is all from start to finish. It's all on the README. I coded it for you guys. But we're going to initialize a gaming window. And to do that, we're going to create a class called game. This game is going to have an init method. And it's going to hold the main functionality of our game. To start Pygame, we have to specifically initialize it, right? By using the .init method. What this tells our code is, hey, I want to start everything that Pygame has to offer and utilize the methods that come with it. All right, so this is going to initialize the Pygame module, giving us access to the methods. Afterwards, now that Pygame is initialized, what should happen is that we want to create a screen. So when I create this game object, it's going to automatically run this init method, which is going to start off the Pygame module. And I'm going to create a data member called screen. Now for all this, I want you guys to keep these data members not private, only because we're going to be writing a bunch of data members, and I don't want to make a bunch of methods and extend our time to access these data members. So we're going to keep everything not private. We're just going to go ahead and just do self.screen. And Pygame gave us a method that allows us to create a window for us, right? So we have to call the module Pygame. And we're going to use the .display method. The .display method, right? This specific method has a additional method that comes with it called setMode. And what setMode does, it allows us to set the size of what our screen should be. We are going to set this to, let's say, 500 by 500 to test it out. And we're going to keep it just like that, nothing else. Now, the next data member we have to create is going to be a clock. Now, why do we need a clock? Well, your program needs to be able to track the time that's elapsed as your game is running. It uses this clock to keep track of every single time that it's checking something happening in your game. All right, so we create a data member called clock, and we start this clock by using pygame.time.clock with a capital C. Now, this is the bare foundation of the actual object. Next, we're going to create a method that's going to start our for loop, and we're going to call this run. Within this for loop, we're going to set, or within this loop, we're going to set a variable, say while true, I want to do something. And what we are going to do is we're going to start a for loops with for event and pygame.event.get. Now, what is this? Well, when you start a Pygame module, as I mentioned to you guys, it's making continuous checks over and over and over again while the game is running. Right? These checks, as I mentioned, can be a keyboard stroke. It could be you pressing your mouse. It could be you moving the coordinates of an image. And all this is saved within I think it's a dictionary that's stored in what's known as events, right? This dictionary is called event, right? It's actually closer to an object itself. But all this information is being tracked within this object called events. And what we're going to do is we want to grab all the events that are happening by using .get. The .get is going to return to you every single event that it is checking for. So when we grab it, we want to loop through every single event and do something. What we are trying to do is check if one of these events is equal to the event of quit. right? By grabbing the event, we can access one of its attributes, which is the type of event that it is. As I mentioned to you, there's different events. It could be a mouse click. It could be a button press. It could be the action of quitting. And we need to do this to be able to exit out of our window whenever we want. So we're checking if at any point we decide to quit. I want you to actually go ahead and quit. There's a method for it called .quit. And then I want you to also manually close the window. And to do that, we have to access our system, which we currently don't have access to. So we have to import the module that manages our system. Where we say import sys at the very top, which then allows us to use the module sys, which then closes a window on your computer. Right. I'm not quite sure on the actual functionality of how sys works, but it controls the windows of your computer. Right, and we can control the actions of it. So by having one of the events being quit, I can manually tell my computer, I want you to completely close out of this window. Very similar to when you guys press the X button on a browser or VS Code and you're trying to close something out. That's what we are manually doing. We are saying, hey, I want you to close this window down. Right, we are manually programming this into here. Finally, and within this while loop, after we're done with this for loop, we are going to say command of pygame.display.update. This method is going to update any changes that are happening on your window as the while loop is running. Every single time that this runs some kind of loop throughout your game, it's going to update anything. Once again, if you move an image, it's going to update it on your screen. So it requires this method. And then we're also going to set the timer speed to 60. And you can kind of already see what this is. It's the frame rate of your game. So if you're familiar with anything about frame rates, if you ever play like games like Call of Duty, whatever, we're setting that limit to what our game should play in. And the frame rate is going to be 60 frames per second. And that is it. Now, Roger, where are you getting all this from? This is straight out of the documentation. They have a quick start, and it just took a little bit of kind of deciphering, kind of going through and seeing what it does. These methods are pre-built into the Pygame module of how to set a window, setting the clock, so on and so forth. Now, this is a little outdated, so it might look a little bit different from how we have it, but that's no biggie. But with this game class established, now we are going to create a variable for our game outside of the class. We're going to say my game is equal to, and I'm going to instantiate this game object. And I'm going to run this game. So when I run this file, it's going to create a game object, which has a screen of 500 by 500. It has an internal clock. It's having the loop that's checking through all the events. And I have the ability to exit out of it. That is it. That's all this is doing so far. And now I should be able to go to my Python file and run main.py. And it should give me a very basic window, which is going to be the canvas that we are going to be working on. As we see here, I was able to add all this functionality inside of a class, give it into its own data members that holds some kind of variable. I can run a for loop that does something, and in turn resulted in a blank screen. Pygame is not the only module that can do this. If you are interested in stuff like this, you can kind of look through all the different modules that Pygame offers you. I'm sorry, not Pygame, Python. Python has this other module that I'm thinking about replacing this with. And I forgot the name of this module. when I was working with it. But this module allowed you to create interfaces for applications. Or I guess not interfaces, I would say GUIs. It's called tkinter. And I'm only bringing this up in the event you guys are interested in stuff like this. Especially if you guys have like a business or you have a bunch of stuff that you work from home. But it allows you to create GUIs like this. These are outdated, the white ones. This is what it more normally looks like. Just like I'm using Pygame right now to create some kind of game window, there's other modules that Python has that let you do different things. And tkinter is one of them. If you, for example, let's say you have a business or you're trying to maybe create an application at home to keep track of like your finances or anything whatsoever, you can create a graphical user interface that has buttons, displays, and you can do things like this. Now, this is a very generic, it's a demo to show you what it looks like. Notice how the buttons have generic names, generic text and stuff, but you're able to create different things with Python modules. So with this code that you already know, it's just looking to the documentation of these modules to learning the functions that utilize this, right? And there's so many tutorials out there. You can look at the documentation that allow you to do this. Pygame is just one of the many different modules out there. But tkinter is a great module if you want to create GUIs, or if you're into small hobbies of using Python, you can create games you like too. All this, we're going to be doing it with objects. Do you have any other questions about this assignment so far?
Not a question, just an observation. This Pygame is, or I'm sorry, not Pygame, but the display and the loop we created for running display and pygame.display.update, it's similar to the JavaScript canvas, is what it looks like.
I've never used that JavaScript canvas. That sounds pretty cool. I'm assuming something very similar to tkinter as well. Is that correct?
Canvas is something you built into JavaScript that you can build graphical user interfaces, games, like anything you want to display visually using JavaScript.
Oh, that's cool. Okay, yeah, no, this is awesome. Yeah, this is a pretty cool tool. I have not used it myself, but this is something that I would definitely be interested in later on looking into. Yeah, it's pretty cool. Thanks for bringing that up. I've never heard of this one. Yeah, no, this is pretty cool. And these are useful tips. You know, like I said, you know, coding can do a lot of things. It's not just for like web applications, but you can leverage your coding skills to dive and dip into different other things that might pique your interest. And this is a small amount of them. All right. Now, let's go ahead and make an update to this. So far, this is looking good, but this is not very appealing, right? It's just a blank screen, but at a minimum, it gives something to work with. Now, for us to actually add something to our game, we need to create what's called a surface, right? And this surface is like this, and I'll explain it using TL drop. What we just created was our game window. Think of it as a layer, right? This is our game window, which in turn is almost like a table, right? Well, the way that everything else is going to work is we're going to create other layers and set it on top of this table. The next layer we're going to create is going to be what we call a surface, right? And this is going to be the background of our actual game, right? We have to create the game window so we can stack things on top of it so we can see it visually. You can't just put a surface out of nowhere. So we had to create the game window first. Next, we're going to create a background and put it over our game window or our table, right? And the way that is called is a surface. So to do that, we are going to create the surface. Within our init method, what we're going to do is say self dot base surface. Right, we're going to create a surface for our background. And to create a surface, we're going to use the pygame.surface method. And it works fairly similar to the display, where it takes an argument to show you the dimensions of what our game should be like. And I don't like 500. I feel like it was too small. Let's go with 800, kind of like Bricklin said. And because I want my background to take the entirety of my window, I'm going to set it to 800 by 800 as well. All right, so here's my surface, but as of right now, that's it. It's not actually on my game, right? If I want to add this onto my table or my game, right? If I want to stack it on top of my game window, I have to manually do that myself. So what I'm going to do within my run loop, when my game's running, between the for loop that's checking for all the events and the section that's updating my game, I'm going to have the actual section where I'm going to be adding things to my window. And I'm just doing this to kind of mark off where my work is going to be at.
On lines 8 and 11, do we need the double parentheses for the methods or to invoke as far as throwing the 800 800?
Correct. You need the parentheses because if you look here, when I go to create this surface, here we see what's being passed in here. It takes one argument, but the first argument is going to be the size, which is the coordinate, right? And this is supposed to be a tuple. And there's other things you can add in here, but the first one is supposed to be a tuple, which is the coordinate. After that, you can add flags. You can add depth. You can add mass. As you see, it's going to the next sections. The first one is the size, which is coordinate. And it doesn't show it here, but it's actually a tuple. And I could probably go to the definition here and see what it looks like. And I don't see it showing me, but that's okay. Just know that it's supposed to be a tuple of two different numbers. Sound good?
Yeah.
All right. Well, coming back here, within this while loop, I'm going to go ahead and add my surface to my screen. And to add something to your screen, you have to use the command screen, right? I want to grab my screen that I created. So I'm going to grab it. And the screens or displays, whenever you create a display, it has a method called blit. So I'm grabbing my game window and I'm going to blit something on top of it. Essentially place something on top of it, right? That's what I'm doing here. I'm grabbing the screen data attribute and I'm going to blit something on top of it. And it takes a couple arguments. The first argument is the surface, as you see here, that you want to add, right? And I already have surface. It's over here. So I'm going to add self.space surface. And the second argument is the destination, right? Which essentially is where do you want to place it on your screen. And I'm going to show you how this will work. But first, let's go ahead and set it to 0, 0. Right, I am adding the surface to my screen and set it to 0, 0. And why is it 0, 0, Roger? Well, the way that your screens work, once again, I like drawing. This is your monitor. There is a bunch of pixels on your monitor, right? Everyone knows this. Well, how do you know which pixel is where and where does it start? Well, your pixels start at the top left corner of your monitor. And the location of that is 0, 0. right? From left to right, this is your x-axis. And from top to bottom, this is your y-axis. In your tuple of coordinates, the first number is x and the second number is y. If I increase 0 by 10, it's going to shift the coordinate to the right, right? A positive version of x is going to go to the right. If I say negative 100 within the x parameter, it's going to go to the left, right? And then same thing with the y-axis. A positive version of my y-axis will bring me down, and a negative version of my y-axis will take me up. So when I say 0, 0, I am pointing to the very top left point of my screen. Let's say my screen is 500 pixels by 500 pixels. If I wanted to get to the very center of my screen, I would have to go 500 to the right, and then 500, I'm sorry, not 500 to the right, 250 to the right to bring me halfway, and 250 downwards to bring me halfway, right? And it should point me right here. This is 250 by 250. Make sense? That's how that's working. So as of right now, what I'm saying is I want you to put my surface at 0, 0 of my window. And you're probably referring to, well, how does it know? Like, what corner of your surface is it? Because everything is rectangles, as we already know. It's a bunch of boxes. It's referring to the top left corner of my surface. I want to add it to the top left corner of my screen. So once I add that surface, I then need to draw on the surface, right? So I'm going to go ahead and draw on it. I'm going to draw on the space surface. It's already on my screen, but now I actually have to do something on the surface. I can't just draw on the table, right? Think about your kids. You don't let them just draw on the table. You give them a piece of paper so they can draw or color. That piece of paper in this analogy is our surface. The table is our screen. So if you want to paint something, we're not going to paint it on the table. We're going to paint it on the surface. And that's exactly what we're going to do. We're going to access our surface, and we're going to say dot blit once again to add something to the surface. And what I'm going to do is I'm going to give it an image. I'm going to say pygame.image.load. I'm going to load an image onto this surface, and it takes an argument, and the argument is the file name, right, or the location of it. Well, everything is already there for you in lesson 10 under assets. So you're going to specify that you want to go into assets, and you're going to grab the outer space.png. Outer space.png. Capitalization does matter. Jay said his Wi-Fi is really bad. He had a drop. That's okay. We will continue. So we loaded up the surface or the image into your surface. Now, the second argument that Blit takes, as you already saw earlier, is where we want to add it. Once again, we're going to start it at 0, 0. Now, let's run our code, see how this looks like. When you run your main.py, it instantiates your game object, right? It now creates the window. It has the clock, but it also now has a surface data member. We use the .run method, which opened up this screen. It runs the game loop. It adds the screen, or I guess the surface to the screen, and then the surface has an image on it. And you should have something that looks like this outer space image. Does everybody have this?
No, I don't.
What does yours look like?
It loaded and then it closed, and I got an error.
What's the error?
Says module object not callable.
Let's see. You mind sharing your screen real quick?
Sure. I also noticed that lit here is not being recognized, so that means I screwed something up above it.
Base surface. It's a comma. Line 10 should be a comma, not a period. 800 by 800.
Oh, awesome.
Try it now.
Nope.
Module object pygame dot surface. I think it has to be, let me see, capitalize the surface. On line 10, the word pygame dot surface. Surface has to be capitalized. Run it.
It's don't. Okay, there it goes.
Now you change something.
Line 19.
Right here, this does not match. Well, could you change the name of the variable, but that's not what I meant to change. Now
tuple.
You have, I think, an extra parentheses somewhere. Take off the parentheses, the blue ones right there. Take those off. Yep.
All right.
There you go. Cool. Awesome. Yeah, so good to go. We now have our background. Everything's going good so far. But this is not too pretty so far. We have something we can work on, but we want to actually be able to do something here. So now we're going to create our hero. What we're going to do is, once again, we're going to go ahead and create a new file in lesson 10. And we're going to call this spaceship.py. Here's where we create the class for our spaceship hero. So what we're going to do in here, once again, we have to import Pygame. And we're going to create a spaceship class. This is what's going to instantiate our spaceship. We have to initialize our spaceship with self. And there's a couple arguments this spaceship object needs to take. Well, if you want it to look like something, it should probably have some kind of image file. So we're going to add image. And it needs to have a X and Y coordinate of where I want this to appear. We are then going to instantiate our objects. I'm sorry, not our objects, our not instantiate. We're going to declare our data members.
Yeah, I'm gonna have to get in and out. I feel like when I opened that game, it like locked up my VS Code and I can't even force quit out of it. So I'm gonna have to probably quit and just jump back in the room.
That's fine. Let's go ahead and take a 10-minute break because it is probably 7:30. I'll see you guys at 7:40. We'll take a quick pause.
Okay.
Yes, we're gonna go over the spaceship.py. So we're gonna recreate or we're gonna create a new file for the spaceship object, right? This should be its own individual object itself. Now it's only gonna be one spaceship, right? But what if you wanted to make a multiplayer game, right? To have multiple different heroes, then obviously an object or a class would help. So you don't have to keep recreating this spaceship. But the fact that we're using an object really helps because not only can we give it data members, which are essentially just variables that hold values, we can let this object do different things with these data members, right? These values. And it's going to help us be able to isolate the code that belongs specifically just to the spaceship in one location, which is why objects are so helpful. So we're going to define this class. It should take in an image, which should be whatever image you should have. Sorry, got a phone call. But it also going to take. It's also going to take an x and y coordinate, right? Which is where we want to place our image at. Now we are going to create the data members for the spaceship. So we'll say self.spaceship surface, right? So just like we need a surface so we can add the background to our screen, we need a surface to add the picture of our spaceship, which we can then add to the surface of our background, right? And it kind of goes back to the way that this is supposed to work, where we have a bunch of screens, right? We have the table, which is the initial display. We then have the surface, which is the background. And what do we do to this surface? We added another surface on top of it, which was the outer space PNG, right? We blitted this onto it. And on top of this, we're going to add another surface, which is going to be actually smaller, right? But this surface has an image on it, which will be the spaceship, right? This will be spaceship PNG. And this is the spaceship surface. Now, it's not going to be the same size as everything else, which is why you see it's smaller. But this essentially becomes our little playground where we can move stuff on top of this surface, right? So it's all layers on top of layers. And all these are isolated within the same objects. This is one object, and this is another object. So with that in mind, we want to create our spaceship surface. And this is going to be a little bit different. It's not the same syntax as a regular surface, right? Because this is not necessarily a background, but it's just a little image. This is what's going to be our characters, right? So it's not a background. It won't be the conventional surface that we created here that lets us draw stuff onto it. This is its own thing that's going to be represented by the pygame.image.load and whatever we pass in as an image. So maybe changing this name of surface to just spaceship could help us understand a little bit better. Maybe adding surface to the end of this is a little misleading, but this should just be the image. And now we're going to start something new, different from what we've done so far, which is giving this what's known as a rect, which is in turn short for rectangle, right? This kind of goes back to what I mentioned about collisions, right, with games. How does Call of Duty, when you shoot your weapon and attack an enemy, how does the game know that you hit the enemy? Well, under the surface, what's happening is that there is a bunch of rectangles surrounding the image of this character, right? Which are known as collision boxes. They're just invisible rectangles, right? I'm assuming everyone's somewhat familiar with this or has heard of collision boxes, right? They look something like this, right? And for those of you that played, I believe this is Tekken, or I want to say it's Tekken or Street Fighter. It's one of those.
Street Fighter 2.
Yeah, Street Fighter, Tekken. I haven't played these in forever, but we don't see it. But the game in the code, there's actual boxes that represent different parts of the anatomy of the player, and then the other player has its own individual boxes, right? How does the game know when something got hit or touched? Well, it uses these rectangles, which have their own coordinates, and it checks when these rectangles intersect. When a rectangle intersects with another rectangle, we then do another action like lower their HP, right? And then if their HP gets to a certain point, then we destroy this player, right? Make sense? So that's essentially what we're doing here. We're going to create a rectangle for the spaceship that we can use to not only understand when something's colliding, but so we can move it on our screen. So in this rectangle or self.rect data member, and this has to be called this. It has to be called .rect. This is one of those magic things that Pygame can only recognize this if it's called rect with no underscore and nothing. It's just rect. What we're going to give it is going to be a spaceship data member, which is what we defined above. Right? It's this. Oh, let me remove this trailing underscores. We're going to pass in the image that we loaded up, and we're going to give that image a rectangle by using the underscore get rect or the get underscore rect method. Right? So we save the image into a variable, and then we call that same image and use a get rect method on it to surround it with a rectangle. And this takes a couple arguments, but the one that we're going to take is going to be mid-bottom. But what is this argument that you're passing in, Roger? This argument is supposed to be where I want to place this rectangle at and how I want to place it. Right? I want to place it at the middle and bottom portion of the image. And we'll see why this makes sense in a bit. But the get rectangle is placed wherever the x and y of this coordinate is at. What that means, whenever I move the image of my spaceship, it should also move the rectangle, because it's going to reflect the x and y of the spaceship. Next, we're going to create a small get method called get position, so we can grab the rectangle x and y coordinate. Right? We're not going to manipulate the x and y of the spaceship directly. We want to manipulate the rectangle, because the rectangle is what's holding the image. Right? The rectangle is almost like the equivalent of the surface for my character. So if I want to grab the location of the image, I in turn want to grab the location of the rectangle, because the rectangle has the image in it. Right? So therefore, if I want to grab the position of my spaceship, I want to get self.rect. I'm going to say .x and .y.
Rect is built into normal Python, correct? Not built into that's not a module or anything like that.
This
When you say self.rect for it, because you said it had to be named rect, so self.rect, so rect is a part of native Python.
It's native to the Pygame module.
Okay.
Right? The Pygame module will only be able to read this self.rect, nothing else. If you do self.rectangle, self.underscore rect, it won't know what this is. You'll get an error.
Okay.
So when Pygame reads your code, it's looking for a rectangle data attribute, so it knows what the image is.
Okay, so if you didn't import Pygame, it wouldn't even know what rect is, or it wouldn't have any significance, the .rect, if you didn't Pygame.
Correct. I will get an issue. This get rect method is coming from Pygame. Right? All these methods we're using, I'm not utilizing. I didn't create them myself. These came from Pygame. Right? This comes from Pygame. And I can right click, go to definition, and it opens up the surface code for Pygame. You can see Blitz, all these different methods that Pygame has. This is where they come from. Right? We create that data attribute, and now all I'm doing with the get position getter method is just grabbing the x and y from rect. Because what this does, it creates an object. Right? This creates an object of a rectangle inside of this class, which is why we're doing .x and .y, because this is a data attribute of this rectangle object, believe it or not. now that our spaceship's defined, let's go ahead and actually create our spaceship. So we can go back here and do the same thing that we did earlier, where we can blit it. And let's try that. We're gonna go ahead and import our spaceship at the very top. I'm gonna say from spaceship, import the spaceship class. Within the init method, just like we were able to create surface in here, I'm gonna create the spaceship. So I'm gonna say self.ship is equal to, I'm gonna call it spaceship class, and I'm gonna give it the parameters that we identified, which is, as we know, the image file and the X and Y location of where I want to place this. So once again, because the file path is an asset, we have to say assets / dir spaceship .png. dir with 3 R's. I don't know why it's called like this. That's just the ship I found. And we're going to give it its location for X and Y, which is going to be, let's say 400, 400 for now. So we can see how this works. Right. Where am I getting this information from? Well, that's how I defined it. My spaceship class takes an image, it takes an X coordinate and a Y coordinate. So I'm going to pass this into it. All right. Well, we come down here. And I'm going to grab the space surface again. And what I am going to do is I'm going to add my spaceship on here. So I'm going to say .blit. And I'm going to pass in the spaceship. And how do we do this? Okay, let's do this. Let's not do it this way. Let's create a method for it. I know we did like this for the surface, but let's go ahead and go to the spaceship. And we're going to create a method called draw, which in turn will take in a screen. This method is going to use the screen that we pass in. We're going to use the blit command on it. As we know, we need a surface that it takes. So we're going to pass in our spaceship in here, self.spaceship. And the location of that is going to be the rectangle. And let's see how this works. Over here, back in here, we're going to call that spaceship we created self.ship. Self.ship. And all I'm going to do is call the draw method. And when I call it, I'm going to pass in the surface that I want to add, which is the space surface. And let's see how this works. Okay, there you have it. So what happened here? I created my spaceship. Instead of just manually doing self.spaceSurface.blit and pass in the self.ship, which in turn I needed the spaceship data attribute. And then the rectangle. I use a method instead to handle it, which reach the same outcome, right? Where one has to be the image you're loading up, and where's the image? Well, it's saved into the spaceship attribute. And what's the location? Well, whatever rect is, which is the same thing that we takes here, right? The image and the coordinates. But the coordinates are currently within the rect attribute we created, and the image is in the spaceship attribute we created. And we're blending it onto the space surface. We can either do it like this, or we can also do is what I did earlier, create a method where I can handle it directly from the object of the spaceship itself. That way, the spaceship just draws itself. It isolates that code and makes it look a little bit neater. But both methods of these are the same. We're both grabbing the space surface, adding the spaceship image onto it, and giving the location of where the spaceship should be. Right? And it should look like exactly this, where the spaceship is dead center on our screen. Now, this isn't exactly how Space Invaders really works, or Galactica. Usually, you start at the very bottom, right? And to do that, if I know that my screen is 800 by 800, I know that my Y should probably be somewhere around the 800 mark. So let's do some formatting. Let's go ahead and say spaceship is going to be 400 by 800. Run it again. And I see it's down here. Perfect. And I can keep it there at the 400 mark for the X. 400 to the right, 800 to the bottom. And because we use the mid bottom as our section, it's formatting the very bottom part and the middle of our spaceship to format it onto my screen. Right? That's why we use mid bottom is equal to X and Y. You can give it other ones. I think you can say top. I think you can say left. I think you can even say center. Look what happens when I use center. It uses the center of the image to take the X and Y location. But we don't want that because that looks pretty ugly. So we can just say,
is there a low bottom instead of a mid bottom? Does that make a difference?
mid
spaceship, like a low bottom instead of mid bottom.
Low bottom.
I don't know. Maybe not.
I think we can say bottom. Oh, bottom didn't work. There's a couple ones that go to. Let me see if I can see the definition. Of course, it doesn't show me. But this is coming from the documentation. If you want to see more of it, of which option you can use for this. But I use mid bottom. We can go to the pygame.org. We can go to docs. And if you go to rect, let's see, where is it at? Rect, surface. Let's look for get rect. There's center. There's some more here. See example for pygame.getRect. People have like whole repos for this, but there's other options you can use. You just kind of look through which one you want to use. But we won't dwell on that too much. But mid bottom takes care of where it's going to place our spaceship. And now we finally have our hero. If you did this correctly, you should have background, and you should have your object with the image of our spaceship at the very bottom of your screen. Is everyone here so far? Okay.
I guess I'll run it real quick. I just hope my computer doesn't lock up again.
Sure, give it a try.
Okay, it looks good, and it didn't lock up.
Right on. Okay. Now it's cool and all, but our ship doesn't do anything. right? We want to make it interactive, which is the main point of this. We got a spaceship class, right? We isolated the image of the spaceship, its location. We're even able to grab the position, which is going to come in handy later. And we're able to give the blip method into this specific object, which we can then instantiate within another object, right? Going back to what we did before, how other objects can instantiate other objects. That's exactly what we just did. Our game class was able to create a whole object the moment that we instantiate game, right? On line 38, because this is all we're doing. All this is being ran with 2 lines of code right here. One is creating the game, and the other one's running it, right? This main file is able to create a whole screen. It's able to create another object within it and save it into a data member. And then that same object we created, we can even use it in other methods. And that's the beauty of objects and classes, that you're able to encapsulate all the different code, have it neatly formatted, and make it do things. And as we saw now today, we can even visualize it too with the help of stuff like Pygame, or if you use tkinter or something else. Now, let's actually add some functionality. As of right now, it's not doing anything fancy, right? And this is not really pretty. So let's actually make it do something. And as we talked about earlier, there's events that we are tracking throughout the entirety of this game loop. Let's see how this works. I'm going to go ahead and say, within this, well, I told you how this is running multiple times over and over again, right? It's starting a for loop and grabbing everything within pygame.event.key. Let's go ahead and print out what the event looks like, so you can visualize what's happening. Don't do it. I'll do it on mine. I don't want your to crash, Jason, but I'll run it. And as you see here, it is constantly running some kind of loop. And it's just too much, I think. But it looped through everything. We see mouse motion. Oh, it's not running anything because I'm not, look, I'm moving my mouse over the screen right now. Right, this is what this while loop is doing. It grabs some kind of data attribute from the event of Pygame that's tracking all the stuff that's happening on my window. And one of these is mouse motion. I can click mouse button down, mouse button up, over and over again. And it tells you the position, right? What button it was. Touch is equal to false, window none. So this dictionary that the .get of event has is tracking so many different events, and we're going to use this to our advantage, right? I didn't make this. This is coming from the Pygame module, right? And that's why we have to use that for loop, right? Because it tracks everything that happens on your screen. And using this event, we can do things like when we want to shoot, we're going to try to find the event for the mouse of click, right? When we move left, I want to get the event where I'm pressing a specific button, so on and so forth. This is what's going to add the functionality to our game. So let's go ahead and close this out. But maybe this gives you a better picture now of what this for loop is doing when we're running. It's constantly running that check over and over and over and over again while this window is open. This is the game loop. Let me go ahead and clear this out. And now that we have that, let's see how it actually looks like in our code. How do we actually add this? Well, what we are going to do is we are going to manipulate those events and look for a very specific event. All right, this event is going to be when something is happening. So while we're doing this for loop, we already checked for one. We checked if one of the events is quit. Let's see if event.type is equal to Pygame.mouse button down. Where am I getting this event? Once again, from the documentation, right? There's an event called mouse button down that tracks when you click your mouse. And all I'm going to do is print mouse is down. And that's it. so we can see how this works. I run it. And I'm printing something out somewhere. Oh, I never got rid of this print statement. My apologies. Run it again. And there you go. Mouse is down. I'm pressing my button. So I'm able to capture when I'm clicking on my mouse. And I'm going to use it to my advantage to be able to like shoot or move. Well, I'm going to put a pause on this. That was just an example. Let's actually tackle the movement first. This is not going to be exactly in the event. We're going to do something different. We're going to say keys is equal to pygame.key.getPressed. The same way that we're able to check for events for a mouse button down, we can check when keys are being pressed, but this one's different. This one isn't specifically in the event dictionary. This comes from the key dictionary. This is a whole different dictionary of its own. And to grab the keys that are being pressed, we have to use the getPressed method. And this one, if we do print keys, it's going to continuously print every time this loop runs the status of all the keys. As you see, they're all false because nothing's being pressed. But notice when I press some keys on my keyboard, it's moving. It's just too fast because it's constantly printing them out. That there are some keys that were turned to true, which is why you saw the shift. It's just printed out multiple times because it's a big dictionary, right? It's a big dictionary of all the keys you have on your keyboard. Let's see if I can find the true. It's a lot, way too much. That's how fast this is running, that it's hard to even see where the trues are at. But the same way that we're able to grab events, we can grab the status of the keys. So with that in mind, every time this loop is running, I want to grab all the key statuses. And I want to check if keys, and I'm going to grab a specific key, pygame.k_A. This is the code for the key of A. Then I want to do something, and we'll put path for now. And we're going to do this for the keys of A, W, WASD, right? You can use the arrow key. I don't remember the code for the arrow keys, but we're going to use the WASD keys to move our spaceship. And we're going to do this for the other keys, pygame.k_D. This is the D key. We'll just pass for now. We're going to grab the W key. Pass as well. And we're going to get the S key. This is the key value pairs to grab the status of the S, the W, the D, and the A key. And we can see it work. Print A. You don't have to do this.
So you wouldn't use if and elif, you'd use four separate if statements in this scenario?
I'll explain why we would do it this way in a bit. But yes, you'll see there is a difference of how that works. Because what happens if you press two different keys at the same time? We need to handle both of them, right? Print S. Now let's look at this. How is this working? Well, now I still have the mouse down one, but if I press S, I'm holding the S down. It's constantly checking that the S is if it's being pressed down or not. So every time I press one of these keys, I'm printing out the respective string that represents it. So every time this loop is running, hundreds and hundreds of times every second, it's checking what keys are being pressed down. If the WASD keys are being pressed down, I want to do something. So as of right now, I'm effectively being able to capture whenever one of these turns true. Now, with this in mind, we're going to do a little exercise, see if you guys can handle it. We're going to create a new function for our spaceship so we can move, right? We already connected the keyboard. You just saw that. We were able to keep track of what keys are being pressed down. Let's use that to our advantage. And whenever we press either the W, A, S, D keys, I no longer want to just print S. I want to create a function that I can use, or a method, right? As you've already known, that classes in objects, we have methods. Just like we're able to use the self.ship draw method, we should be able to create a method that's like self.ship.move that can move depending what key we're using, right? So this method should belong to the spaceship. We'll say define move. It should take in self. And I'm going to leave this part up to you guys, what it should take as an argument to figure out how it should move to what side. Now, Roger, how do you move your character? Well, how did we position him in the first place? The X and the Y coordinate, right? So whatever X and Y is going to represent where my character is at, right? Whenever I drew it using the rectangular data attribute, which, as we know already, it has an X and it has a Y. So if I want to move the spaceship, I probably have to manipulate the X and Y of my rectangle, right? Everyone still with me? Okay. Well, with that in mind, I want you guys to be able to use these keys to call the move method and then in turn shift the hero. Fairly simple. Don't overthink it. Take it one step at a time. Move them left and move them right. And then move them up and down. Time is 8:13. Let's take 10 minutes for this and see if you can do it. This does not need any Pygame methods, right? I've already pre-built it for you. It's just manipulating data attributes, right? And calling a method. So don't overthink it. We'll come back in 10 minutes at 8:23. Were you guys able to do it?
I don't know. I mean, I didn't test it.
Okay.
I did try something, but I don't know if it'll work or not.
Any kind of movement at all?
No. I mean, I literally just finished as soon as you came on, but I haven't tried it. But I'm not thinking it'll work.
Okay. Try it. Tim, how are you doing?
So the event type that I'm listening for is mouse button down. So I don't know how to convert that into keys.
You are trying to move with just your mouse?
No, earlier you had to say if event type equal pygame.mouse button down and then pass. So that's the only event listener that's actually happening right now. It's not listening for buttons, right?
Yeah, so looking at my main code, are you still looking at my screen?
Yeah.
I demonstrate how we can look for events
Mm-hmm.
within the for loop, right? But then I mentioned that we're going to come back to this later.
Mm-hmm.
And then outside of that for loop, what we are doing is grabbing the dictionary of the keys that are being pressed.
Yep.
Right? This is outside of the event. This is not an event in itself from the event dictionary. This is a different type of tracker that we have. And this is going to return to us
It didn't work.
It didn't work. Okay, that's fine. We'll move forward from here. I can show it here. So this is not an event. This is a dictionary of keys with their status, whether false or true, right? And after we grab the dictionary, we check if one of the keys is being pressed. Oh, I'm sorry. We say if keys this or this, right? We're checking different keys, but notice that we're doing an if check on a Boolean, right? So what this is saying is if true, print A. If this is true, print B, right? And so on and so forth, because the status of this are either a true or a false value. And we saw that when I printed out keys. where is this? When I printed out keys, it printed out only status, right? And maybe saying that it was specifically a dictionary is not exactly correct. It looks like a tuple, but it returns to me a booleans of every single key value pair that we have in this dictionary, right? Some are true, some are false. Well, we access that dictionary by grabbing the key. And as we know, the value is a boolean, right? Because this is what it is. Keys is a dictionary that has key value pairs of a key. This is the key for A, and the value is a boolean, which is false or true.
Yeah.
This is the key for D, which is false or true. So when we say if this, it's going to return the value of this key, which will either be false or true, right? And if it's true, we're going to print out A. If it's true, we'll print out B, and so on and so forth. So that's what we're looking for here. Now, the way that this should work, though, is that we don't want to print something. If I'm pressing down the A key, what we said is that it should be able to run the self.ship.move method, right? It should run this method here.
I mean, I was playing along the lines of like coordinates, you know, as far as thinking I would move one to the left, one to the right, one up, one down, using X, Y. I just, you know, I just couldn't get it to
Okay.
run.
Well, let's see, right? It should take you the direction. So it takes one argument, which is direction. If I'm pressing the A button, then direction I'm going to pass in here is going to be a string. So direction is going to be a string. It'll either be A, D, W, or S. And let me copy and paste these and then change the direction we pass in. Right? Depending on where we're moving, we're going to add the key that's supposed to represent this.
Oh, I was able to get it to work. I didn't
Okay.
test it.
Oh, right on. Okay, perfect. And after we get that, we're going to say if direction is equal to A, then we should do something, right? If direction is equal to D, do another. If direction is equal to S, do something else. Else, do the other, right? So if it's A, right, that's going to be our left key. Then I should move my spaceship to the left. So to move left to right, we've already identified that's the X coordinate. So if I'm pressing A, I should be able to call self.rect.x, and I want to move left. And as we talked about earlier in our picture, right, was to move left, we have to go negative X. To move right, we go positive X. For Y to move down, we go positive Y. To go up, we go negative Y. So if I'm moving left, I have to subtract from the current X axis, and I'll just say I'll lower it by 5. If I press the D button, that's going to be the right. So I should say plus equals 5. If I press the S, if the direction is equal to S, that means I'm going down. And as we mentioned, to go down, the Y has to increase. So we'll say self.rect.y plus equals 5. And if I am moving, more than likely, if it's not A, D, or S, and I'm calling this method, I should be moving up. So I'll just say self.rect.y minus equals 5. Now let's try it out. Let me go ahead and remove this print statement. I'm lagging because I got so much here. It kept printing out. Lord. Okay. So now if I run it, when I press my keys, I now have movement. And it's a little weird, right? Because I'm using elif statements, right? I feel like it's a little too strict. Maybe if I use an if statement instead of elif, it'll feel a little bit more smoother. Let's try this. If direction is equal to W. It feels okay. I mean, it feels better than it was before. But it should look something like this. Do I have any questions about how we move it? Jason, you're good? Did you get it to work? Are you talking? Jason, you good?
I think almost it's moving like the opposite direction up and down than I expected. So I think I screwed something up.
Okay. Yeah, it's
I'm
probably
just
just
real quick.
you're probably just missing up the negative and positive on the axis, and that's okay. But that's simple, right? All we're doing is manually changing the data attribute that belongs to the spaceship, which is the x coordinate. All right. Let's go ahead and continue. So, as of right now, we have movement, but something happens. Notice that I'm able to move outside of my window screen. And this is not really ideal, right? You shouldn't be able to move out of the window screen. So we probably want to fix this. So what I want you guys to do in the next 5 minutes, I want you to add a restriction to the movements of the spaceship, right? Make sure that, for one, it shouldn't be able to come all the way up, right? Because what happens if we're spawning aliens and we're just shooting them as they're spawning? Maybe not ideal. Maybe add a restriction to how far up you can come. And then it shouldn't go out from the right, the left, or to the bottom, right? So manipulate the movement and see if you can add a restriction.
Yep.
All right. Were you guys able to solve it?
I'm able to restrict the up movement, but the down is refusing to cooperate. I'm not sure why.
Okay.
Yeah,
Let's.
I was just Googling around and couldn't find it.
Okay.
I mean, I figure it was something to do with locking coordinates, of where the ship's going. Huh.
Uh,
So it can't
close.
like go further left or further right than, the screen dimensions or whatever.
Yeah. So when we're moving right, we don't just want to move it whenever it wants. We probably want to do something like if self.rect.x is greater than or equal to what's a left? Yeah. If it's greater or equal to 20, or we can say 10, whatever you want, then we can move it to the left. But the moment it gets close to like 0, we should probably stop it from moving. Right? So we can add some kind of check like this, where once it reaches a certain point in your screen, you no longer want to let it move. Right? And we're gonna do these for pretty much all of these. And before I do these, let's actually see how that works. I can run it. And I worked on the A, so I can see here that when I move to the left, it's not moving my X any longer, right? Because to move to the left, we decrease the X. So I only want to decrease it if my rect.x is greater or equal to 20. So right now, it's reached the 20 pixel mark on the X. So it's not going to move to the left. And you're going to want to do that for the right, for the bottom, and for the top. If we know it's 800 by 800, you want to use those dimensions to your advantage. So to move to the right, we probably want to make sure that we can only move the X to the right if it's less than 800. If we start getting to 800, we probably don't want to move it any further. So we're going to say if self.rect.x is less than or equal to, let's say, 780, then we move it. If not, it should not move. And let's see how that looks like. It's not too pretty. I don't like that. Let's go ahead and adjust it even further. It's too far out. Let's go with 700. And now it should, there we go, a lot better. I could probably adjust a little bit more to make sure it's closer to the edge. But I'm able to restrict the left and the right. And then we want to do the same thing for the bottom, right? It should not go past a certain point on the bottom. So we'll say if self.rect.y, and we mentioned the bottom portion is the positive version of the y-axis, so it shouldn't go above 800. So we'll say if the s is greater or less than equal to 700, then you can increase it. But if it gets to 700 pixels, don't allow it to move. Right? It's simple as this. Take 300 for this one. Let's see what this looks like. Here we go. We have our spaceship. And for some reason, my Y is giving me an issue. I can't move up. If self.y is less than or equal, oh, is it supposed to be greater than or equal? My bad. There we go. There we go. Now I can move up. And I can't move past about a third of the way, which is good. You don't want to come all the way up and just kind of kill them right as they're coming out. But we're able to move the spaceship, and now we have some collisions. We have our left and right limits to the game. So far, so good. Do I have any questions? Tim, you're muted.
Yeah, I saw that. I'm still not able to get the right collision to work.
Go ahead and share your screen.
Oh, never mind. 800 was off the screen. I needed to be like 725.
Yeah, because don't forget, where are we moving the rectangle, the mid bottom. So you kind of have to take that into consideration as well. So you kind of have to mess around with it, and that's okay. This isn't going to be like some game we're going to deploy somewhere or try sell. So it doesn't have to be perfect for every screen, just enough for your screen so you can kind of work around and manipulate these methods. But up to this point, this class had a method that is going to update a data member, right? It's almost like a setter if you think about it, right? This move method is almost a setter that's setting this data attribute. And we're calling it. That's literally what this .move method is. It's really just a setter. Jason, you're muted.
Yeah, it seems to work. Do you hear me?
Yep.
Okay,
Sorry.
It works. It works.
Okay. Awesome. Well, we're gonna stop there. Today is Friday. But let me go ahead and stop the recording.